But in the meantime, I don't know if you've noticed, but all of these equations that you were assigned as practice have as the argument of the absolute value function, which means what's inside, a linear expression. You were not assigned, for example, C and D in question 2, because the argument of the absolute value there is a quadratic expression, and that's what we're going to learn today. But how do we solve these? Let's just pick on, well, I'm going to pick on a very simple one to begin with, only because somebody asked right at the beginning of class about it. Number 4 here has the absolute value of x. The absolute value of x minus 4 is equal to 10. And I'm going to prepare my workspace here in a slightly different way than I did yesterday. I'm just going to say, you know what, that's the same as, I don't want to put an equal sign here. That's the same as x minus 4 equals 10 and negative x minus 4 equals 10. If x is greater than or equal to 0, that equation is true. If x is less than 0, then this equation is true. You with me? What I'm saying in layman's terms or in English language is that this equation of the absolute value of x minus 4 equals 10 becomes, I know some of you were just dying to tell me that that should be a 10, becomes x minus 4 equals 10 whenever you don't need the absolute value signs. And you don't need the absolute value signs if what was inside, which was x, was already greater than or equal to 0. If you do need the absolute value signs because what's inside is negative, because x is less than 0, then you have to remove the absolute value signs and multiply what's inside by negative 1. So what happens when we solve this equation? Well, we get x equals 14. What happens when we solve this equation? Well, I can add x to both sides to get x on the right side and subtract 10 and get negative 14. This is in reference to equation 1. This is in reference to equation 2. The fact of the matter is, on a number line, when we say x is greater than or equal to 0, we mean that. So this is equation 1. When we say x is less than 0, we mean that. So this is equation 2. Is this solution up here of x equals 14 in the domain for the equation that we used to get it? Yeah. That's equation 1. It's in the domain for equation 1. 14 is valid. Is negative 14, this solution, in the domain that came from equation 2? Yes. So they're both valid. If we wanted to check them either instead or as well as looking at the domains, then we would look at the original equation, which is the absolute value of x minus 4 equals 10, and check when we put in, for example, x equals 14. What do we get? We get the absolute value of 14 minus 4. Well, that's 14 minus 4, which is 10. So that's a solution. If you were to check, well, what about x equals negative 14? Well, you would put into that left-hand side negative 14 in for the in for x minus 4. This is the left side. The absolute value of negative 14 is 14 minus 4. Well, 14 minus 4 is still 10. So you get 10 regardless of whether you use positive or negative. I really like just looking at the domain. It's maybe a little bit more work, but a little bit more work mentally to come up with that. But algebraically and numerically, it's more work to physically check. All right, all that being said, does anybody have any questions from any of the other problems that were recommended for practice? Is there a challenge question? Oh, has it got two absolute values? Okay. Yeah, why not? Let me pull that up. Are there any quadratics in there? Okay. That's the question you're looking at, Isaac? Okay. So, what can we do here? Well, let's pretend that there's not the absolute value of x minus 2. Or maybe we just don't notice it right away. In other words, you're absolutely focused on the absolute value of 2x plus 1. And what you do is you say, okay, I think this is a good conversation for us all to have. You say 2x plus 1 would be greater than or equal to 0 when x is greater than or equal to negative 1/2. Would you agree? Subtract 1, divide by 2. What does that mean? It means that this equation would not need absolute value signs around the 2x plus 1 if x is greater than or equal to negative 1/2. Fair enough? Which would mean if we remove the absolute value signs and x was less than negative 1/2, then the argument, the thing in the absolute value, would be negative, which would require us to multiply this by negative 1. And this would be our equation. Okay. Now, can you solve this equation? And I want you to forget about where that equation came from. It came from the question, but just imagine that I said solve this equation. Well, you would say, let's see, you would say x minus 2 is greater than or equal to 0. So if x is greater than or equal to 2, I don't need that absolute value set of signs, which would mean this equation now becomes 2x plus 1 minus x minus 2 equals 2 if x is greater than or equal to 2. And it becomes 2x minus 1, plus 1, minus, now this argument of x minus 2, this is where we got kind of sidetracked yesterday with all the negatives, needs to be multiplied by negative 1 because we are going to now be talking about x is less than 2. So I'm going to have to subtract negative 1 times x minus 2. Really, part of me here, Isaac, just wanted to put plus because it was minus and I had to multiply by negative. Now, before we go on and do that here, look at this equation. You can solve this for x, okay? But there's conditions with x here. X must be less than 2, correct? but it must also be greater than negative 1/2. Because both of these equations came from this bluely highlighted equation where x had to be greater than or equal to negative 1/2. Any solution to that blue equation has to be in this domain. When we separate out the blue equation, we get a subdomain for the first part. This is equation 1. Let's call this equation 1a. Let's call this equation 1b. And any solution to equation 1a, according to the other absolute value, that solution has to be x is greater than 2. So here is 2 over here. Here is 2. So this is equation 1. This is equation 1a. And this is equation 1b. Are you with me? I'm not so much worried here about getting the answers as I am setting up the domains. So let's just imagine that you solve 1a, and you got, for a solution for 1a, this is not going to be the solution, and I guess unless I get a lucky guess, you get x equals, for 1a, you get x equals 1. Is 1 in the domain x is greater than negative 1? Yes. But is it in the domain of 1a? Well, 1a says x has to be greater than or equal to 2. And it's not. So it wouldn't be a solution. And this gets very tricky. Let me rewrite this number line thing. If I had a statement that says the thing you're finding must for sure be greater than that, and then I came along later and said, oh, you know what? Sorry, I forgot to tell you this. It also has to be greater than 2. I hope you see that the x is greater than or equal to 2 overrides the other thing. Because if it's greater than or equal to 2, it will be greater than or equal to negative 1/2. Which means that this domain is the ruling domain for that equation. On the other hand, for equation 1b, for equation 1b, says that. And it has to be in both of those. So really, for 1b, it's that. It's got to be a number that's greater than or equal to negative 1/2, but it's got to be less than 2. So if you get a number in that domain, it would be valid. Now, keep something in mind here, and I don't know if I really want to finish this, but I'm going to erase this and just say to you that equation 1a must be in both of these domains. And for equation 1b, it has to be in both of these domains. I didn't overlap up top here with the colors because I don't think you would see the colors. Now, keep in mind you have to repeat the same process down here for equation 2. because we started off with one equation that we split off into two, and one of those two split off into two, and this one has to split off into two. I'm not going to go any further with it other than to say you could certainly give that a shot. That's why it's a challenge question. You would never be expected to do this in this course. Does anybody have any other questions you would like me to go through or talk about? All right, then we're going to move on here and take a look at the next lesson, which is continuing to solve absolute value equations, but these are going to be quadratic in nature. Okay. So for example, in number 1, you're asked to solve the absolute value of x squared minus 2 is equal to 1, and the argument is a quadratic. So we do the same thing we did yesterday. You create two equations. I'm going to call equation 1, of course, the one where the argument is greater than or equal to 0. This is what I always do for equation 1. Will simply be x squared minus 2x equals 1. Because if the argument is greater than or equal to 0, then I guess you didn't really need the absolute value sign, so you just get rid of them. Equation 2, this is going to be anywhere the argument is negative, is less than 0. We're going to remove the absolute value signs but multiply the argument by negative 1 to make it positive. Because if the argument is negative, absolute value means make it positive. How do you make something negative positive? You multiply by negative 1. So what is incredibly challenging here, even though it turns out you've been taught how to do this, it still becomes challenging, is what is the subdomain? And it's not simple. Because if it's linear, all you do to get the subdomain, and I can show this to you because we did one here, all you do to get the subdomain is you take that argument, you write greater than or equal to 0, and you rearrange it. So this is what I'm talking about here. It's very simple. You move the number to the other side, you divide by the coefficient. But you cannot rearrange an inequality that way if the inequality has a quadratic in it. So, how do we decide where x squared minus 2x is greater than or equal to 0? How do we decide that? How do we figure that out? The answer is we look at the graph of y equals x squared minus 2x, and we see where it's above the axis and where it's below the axis. This is what you did when you wrote domains for piecewise functions. And I see everybody grabbing your graphing calculator, and that's a natural response, but let's try to reason out what the graph looks like. Now at the top I'm going to put y and here I'm going to put x, but I'm going to add something that is always there but you never really write it. Y equals x squared minus 2x. Okay, I really want you to focus on what I'm saying here. That means I want you to imagine that what's on the y-axis is not called y. You know what's on the y-axis? X squared minus 2x. That's what it's measuring. So if x squared minus 2x is positive, the graph will be above the x-axis where it's positive. If I find the x-intercepts of this graph, which is a very useful thing to do, I can set y equal to 0 and get 0 equals x squared minus 2x. I can factor out the x and have x minus 2. Oh, this is a parabola that has an x-intercept of 0 and an x-intercept of 2. Does this parabola, which is really just our argument in the question, does it open up or down? Up, right? So it looks like this. And we're heading into territory now that's the stuff I've talked to you about before, where you go, yeah, I get it, I'm following it, and then you have to do it on your own. It's like, wait, what am I doing here? But if I say, where is x squared minus 2x greater than or equal to 0, it is greater than or equal to 0 here, here, and anywhere here. That's where it's greater than or equal to 0, because it's above the x-axis. But we don't want to write in this question, we don't want to write comma, here, here, and we have to explain it with symbols. So where x-wise have I highlighted things? Well, I've highlighted things when x is equal to 0 or less than 0. That's the arm on the left, and this should be familiar to you. We did this with piecewise functions that were quadratic. And when x is greater than or equal to 1. So the domain that's highlighted in blue and underlined in pink is the subdomain for equation 1 in this question. Yes? Because I made a mistake. Thank you. The number is 2, not 1. The question, if you can't hear it on the video, is why is x greater than or equal to 1 and not 2? And the answer is because I screwed up. It should be 1. But should be 2. Should be 2. Been a long week, I guess. X is greater than or equal to 2. Is that good? Okay. Where, well, let's write that in. X is less than or equal to 0. X is greater than or equal to 2. Well, you know, what that means is this is the domain. As long as x is in there, it's valid. I really wanted to write, and sometimes I think you may have seen me do this. But I think maybe that's layering on too much information on one picture. Okay. Where is the argument negative? The argument is that graph. That's the argument. Where is the argument x squared minus 2x negative, less than 0? Well, it would be less than 0 not in either of these places, but every imaginable point in between. Looks like a scary face. Every point in between. So that would mean we could put 0 is less than x, which is less than 2. And this subdomain that I've highlighted in yellow and underlined in pink will be the subdomain for equation 2. When we wrote absolute value quadratic functions as piecewise functions, this is what we did. We're doing the same thing. So x is between 0 and 2. What this means, of course, is that if this is 0 and this is 2, x can be any number between those two values. You know, keep something in mind. We still have to solve these equations, right? This is all just thinking going into what the domains are. I'm not going to spend nearly as much time with the other two questions today, but I want to really go slow here. I know from experience that there are going to be students in the class, and I'm sorry, but this is true, that are not capable of understanding this and coming up with these subdomains on their own. I know it. But could you solve, did you need to know the subdomain to come up with this equation? No. Nor did you need to know the subdomain to come up with this equation. And you should be able to solve both of these equations to get answers. When you get your answers, because you didn't use subdomains maybe, you're just going to have to physically check them by putting those numbers in for x in the original equation. Whereas the rest of us, if we use subdomains, we can just look and go, oh yeah, it's in the subdomain, it's right. It's the right answer. But again, if you can't come up with subdomains, you would not get full marks. Okay, let's solve equation 1. I'm going to go where I've got a bit more room. I've got x squared minus 2x equals 1. I want to make sure I wrote that down correctly. I did. So this is quadratic. X squared minus 2x minus 1 equals 0. You know what? Can you change this to a -1 in the question? Is it a -1 already? It's not. Change it to a -1. That doesn't affect anything else that we've done. Okay. Which means when we zero the equation, it becomes this. The way it was would have been non-factorable, and I don't want to start using the quadratic formula here. This factors into x minus 1, x minus 1. So we get x equals 1 or x equals 1. But the bottom line is there's only one solution here. We get x equals 1. Is 1 in this domain for equation 1? No. So equation 1 doesn't have any solutions. Not in domain. On the other hand, if we had this equation for equation 2, don't forget it's equal to -1. I've changed that. We'll get negative x squared plus 2x. It looks like we're going to have to use the quadratic formula anyway. Equals -1. That's okay. We're well versed with the quadratic formula. I'm going to zero this equation and get 0 equals x squared minus 2x minus 1. Is that factorable? The numbers are small, so you should probably be able to figure out whether it's factorable or not without finding b squared minus 4ac, but let's find b squared minus 4ac anyway. The discriminant b squared minus 4ac gives me, I believe, 8. And I'm seeing some people nod. 8 is not a perfect square, so this is not factorable, which means we are going to have to use the quadratic formula. Negative b, which is -2, which is 2, plus or minus root 8 all over 2a, which is 2. Let's simplify that a little bit. 2 plus or minus 2 root 2 over 2. Root 8 is root 4 root 2, which is 2 root 2, we can cancel a whole whack of 2's. In other words, factor a 2 out of the top and cancel it with the bottom, leaves us with x equals 1 plus or minus root 2. Which is two answers. X equals 1 plus root 2. And x equals negative 1 plus root 2. What was our domain here for equation 2, which is what we're working on? Wasn't it that x had to be between 0 and 2? So let's calculate these and see if either of them are between 0 and 2. I have a feeling neither one will be between 0 and 2. This number is very approximately 2.4. Am I in the right ballpark? And this number is very approximately negative 0.4. So there's no solutions to this equation. Go ahead, Kendra. Oh, for the second one? Yeah. And you know why? Because I wrote negative here, and it's actually this. I'm sorry, that's my fault, Kendra. I wrote it down incorrectly. It's not negative 1 plus root 2. It's 1 minus root 2. So no solutions. Take a look at the next one. X minus 10 equals x squared minus 10x. So we get two equations. One of the equations, equation 1, will be x minus 10 equals x squared minus 10x. Now, this one's not bad. This will be where x minus 10 is greater than or equal to 0. Because the argument in the absolute value is linear, we don't need to look at a graph of it to solve it. We can just add 10 to both sides. And get that. Some of you asked yesterday, a couple of you when I was walking around, does that mean that the domain for the other one is, I just flipped the sign? The answer is yes. The domain for the other one would be x is less than 10. So the second equation would be x minus 10 multiplied by negative 1 equals x squared minus 10x. And this would be where x is less than 10. So let's work on equation 1. It's quadratic, so I'm going to zero the equation by moving everything to the side that has that x squared on it. And I will have x squared minus 11x plus 10 equals 0. Which factors into x minus 10 and x minus 1 because we're saying what two numbers multiply to give 10 and add to give negative 11. Which means x equals 1 and x equals 10. Is 1 a valid solution? No, because it's got to be greater than or equal to 10. 10 is way over here on a number line. 1 is not even close to 10. So we get rid of that. It's not a valid solution. But x equals 10 is, it is in the domain x is greater than or equal to 10. If we solve equation 2, I think I might have room to put it on here. If we solve equation 2, I'm going to multiply that negative 1 through the binomial first, negative 1 times x, and then negative 1 times negative 10. This equals x squared minus 10x. I zero the equation. I have to add x to both sides to get negative 9x, and subtract 10 from both sides to get minus 10. Factorable. into x minus 10, x minus 9, nope, x minus 10, x plus 1. Those are the two numbers. So we end up with x equals 10 and x equals negative 1. Forget about equation 1 and what happened with equation 1. Look only at the solutions that we got from equation 2. One of the solutions is x equals 10. Is 10 in the domain of equation 2? No. Don't say, well, since we know it's a solution over here. You have to strike it from the record here. I mean, 10 still survives as a solution from equation 1, but it's not a solution in equation 2. Is negative 1 in that domain that I'm pointing at with that arrow? Sure. So negative 1 is a solution. There are two solutions to this equation. One of them is 10. One of them is negative 1. Number 3. Looking at the equation and looking at the absolute value part of the equation, I hope it's clear that those will be your two subdomains. You start by saying the argument in the absolute value sign, x minus 5, must be greater than or equal to 0 for equation 1. So you say to yourself, x minus 5 must be greater than or equal to 0. And you solve that for x, and you get x is greater than or equal to 5. So one of the equations we solve is x minus 5 equals x squared minus 8x plus 15. And the subdomain is written beside it. The other equation we solve is negative of x minus 5 equals x squared minus 8x plus 15. And you know what, everybody? I mean, quite frankly, this stuff right here is the absolute value math. The rest of this question is basically chapter 4 or chapter 3, going back quite a ways. Let's solve both of these equations. I didn't label them. I suppose we ought to. Equation 1 and equation 2. So equation 1 will be x squared minus 9x minus 20 equals 0. Plus 20 equals 0. Is that factorable? I think so. X minus 4, x minus 5. Boy, it suddenly got very quiet in here. Which means x equals 4 and x equals 5. We take a quick peek at our subdomain for equation 1, which is right here. X has to be greater than or equal to 5. Sorry, buddy. No can do. 4 is out because it's not in that domain. And again, some of you might require, I don't know. It'll only take a second for me to write this. Some of you might require this visual. When I say x is greater than or equal to 5, I mean it has to be in that region indicated on that number line. 4 is to the left of it, so it's no good. 5 is a solution. Solve the second equation. We'll have negative x plus 5 equals x squared minus 8x plus 15. 0 the equation. You check my arithmetic there, please. I'm moving everything to the right-hand side. I have to add x to both sides, so I get negative 7x. I have to subtract 5. I get 10. Also factorable, x minus 2, x minus 5, which means we get two apparent solutions, x equals 2, x equals 5. We're going to look here now at x is less than 5. Well, no, this one's out. And very often that happens. In one of the two equations, you exclude one of your solutions because it's not in that domain, even though it happens to be a solution because of the other equation. And 2, is 2 in the domain of less than 5? Yes, it is. So two solutions to that quadratic absolute value equation, 5 and 2. You could potentially have 4 solutions. I mean, graphically speaking, if your absolute value of your quadratic ends up looking like this, because the original quadratic looked like that, and you have to fold up the negative part, and your other part of the equation is a linear function that looks like that, you could potentially have 4 solutions. For each of the two quadratics, you could get 2 solutions, and they could both be valid. You could have anywhere from 0 to 4 solutions. On your handout, does it say text page 389, number 6? So it does. Oh, okay, good. Finish up the ones on page 28. I think it's page 28 of your handout. Those would be the ones that have quadratics involved. And then here's some extra questions if you need extra practice on page 389, number 6. You can do those as well.